All right, all right. Happy Saturday, people. Ms. Steph here. Hi, hi, hi. Welcome to Science with Ms. Steph, people. So hopefully you're getting good sound. I really wanted to wear the earrings. Hmm. So for my people listening on YouTube, just be warned, you might end up getting like that sound that this kind of thing. We'll see. uh, how distracting that is. Y'all are gonna have to let me know if it's distracting for you or not. But yes, welcome to Science with Ms. Steph, people. All right, so we are on for Science with Ms. Steph. This is our fourth episode of season 2, y'all. And what I'm going to be doing over the next several months um, is I'm going to be flipping back and forth between what you request. Okay. And kind of walking you through some of the stuff that we did during the summer because not all of you could come to summer. One, we were doing the in person whatnot and just making sure. So I'm going to just go ahead and take these off. Y'all already know that they're cute. Okay. I just don't want the sound to be distracting for anybody. Over, of course, on Instagram, y'all are like, we can't hear that anyway because yeah. But still, I just want to make sure that there's nothing that's going to distract you from your learning experience. So yeah, so welcome to Science with Ms. Steph, folks. We are live today. How does that feel to be live again? Yes, 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 yes. All right. So I'm so excited. Some of you are going to have to watch this on the replay because you're like out gallivanting, running the streets, doing whatever you do on Labor Day weekend. Please be safe. Please make sure you have your mask on. Yes, this is y'all science teacher telling you, please have your mask on. Like for real. I'm also going to ask you to wear it properly. Okay. This part will be quick. I promise I will get to today's lesson shortly. But like your mask only functions properly and does what we all want it to be doing if it is over your nose and your mouth. I repeat, over, not right here. Right here literally does nothing for you or the other person. Yes, over your nose and your mouth. It needs to cover this whole entire situation. So yeah, that being said, like I said, wear your mask, and please wear it properly. Welcome to the fourth episode of season 2 of Science with Ms. Steph. Now, for those of you wondering, Ms. Steph, you don't have your regular shirt on. Like you don't have the Science Club shirt on. I know I've been kind of taking a break from the Science Club shirts, just it's summer, okay? Or rather, my part of summer, which is just a few weeks after summer camp. I do have an Engine Design, okay, shirt on. Yes, I know it says 2020 because of like, I bought it in 2020, all right? But for those of you wondering where I got my shirt, Engine Design. Okay, this. All right. My Instagrammers, people, I am about to tag her in right now. So over here on Instagram, if you look, there she is. Boom, 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 boom. Okay. So y'all, this is the shirt. Yeah. Okay. So if you're wondering how to get some of her awesome, cool, biopic gear, do that. Go over to her page. You can order. Go over to her page. You can order. Okay. Cool. So I already did the mask reminder. If y'all are outside, have it on, please. Thanks. I did the letting you know what's going on with the daily fit. Yes, let me go ahead and tag in curly head. Okay. Yes. Daily fit. Okay. Letting you know where I got it from and what's going on with it and all that type of stuff. And now let's talk science. What's today's lesson going to be, Ms. Steph? What are you doing? Like, what are you trying to get done today? Today, I am going to walk you through one of our classics kind of turned on its head. We're going to do a vinegar and Alka-Seltzer tablet, right? Like, so we've done stuff with Alka-Seltzer in it and all that type of jazz. Let's find them. Let's find them. There we go. We've done that, right? We've done, Alka-Seltzer tablet with as instructed on the container, with water and all that type of stuff. Okay. Today, I'm going to walk you through a lesson, walk you through an exploration to make sure that you get an opportunity to kind of see, well, what happens if I change the liquid ever so slightly. So instead of water, we're going to actually use vinegar. But isn't that a little boring, though, to only use one liquid? Isn't that lacking a scientific investigatory kind of experience? Possibly. So why not compare the reaction of water, as instructed, water, to the reaction of vinegar with Alka-Seltzer? Let's find out if the reaction is larger or smaller or what. And of course, as you know, we got to rock and do our surfactant to make sure that we're able to capture those bubbles instead of letting that fizz just go off into the ether. No. We're going to go ahead and capture that fizz. We're going to capture that fizz. Alrighty then. So over here on Instagram, you're going to see me kind of fiddle, okay? Fiddle and make sure that we are inviting all of our friends to come hang out with us. Okay. All right. Wanting to make sure that everyone gets a chance to come hang out. Okay. We've got, let's fix that. Just really inviting everyone to have a good time when it comes to science, right? Science is fun, isn't it? I mean, right? Okay. And so, of course, we want to make sure that everybody gets a chance to have some science fun. Let's throw up our banner over here on YouTube. If you're interested in getting more information about Mid-Steph Science Club and all that type of stuff, definitely check out, of course, the link that I'm flashing here over here on YouTube and over on Instagram. Guys, it is that whole link in bio thing, okay? Link in bio, all right? And if you look at the link in the bio for Instagram, you're going to be able to find like all kinds of stuff. Like I have links to my YouTube channel and to the podcast. Yes, the podcast, which is just me chatting. Okay. So don't go to the podcast and you're like, I want some science stuff. Not what I'm talking about over there. I'm just talking about how I feel that day when I do it. And I don't even have, it's not even like a regular thing. So yeah, that's what's going on over there. And of course, if you want to support Science Club, definitely hop over here on Instagram, link in the bio, and that link that I've got down below there. All right. So once again, in case you are wondering who I am, I'm Ms. Steph, people. I'm Ms. Steph. So thank you for joining me today. Let's go through our materials that we're going to use, and then we'll talk about our lesson, okay? The different things that we can learn, right? So let me go ahead and kind of tilt you guys down a little bit, and I'm going to hold stuff up for you and see how that goes together. All right, so from left to right, which might be your right to left, but whatever. I actually am going to use graduated cylinders today. One of my commitments to you all is that I'm going to do more measuring and also making sure that I'm labeling things and all that type of stuff, right? So that you're clear and that you get an opportunity to really see how a scientist would do things. Just because I have the outfit that I have on doesn't mean that I'm not a real scientist. Hello. Yes, I am. Okay. And so, yeah, wanting to make sure you get in those habits. So vinegar, this is the kind of vinegar that I'm using, store-bought, regular, over-the-counter, just regular vinegar. I am also going to be using Alka-Seltzer. Sometimes I'll use like CVS brand or my Rite Aid brand stuff. Today I'm rocking out the real stuff today. All right. I have, again, rocking out some like fancy materials for y'all. So not only am I doing the graduated cylinders, but I'm also doing these cute little containers. These little bottles are like little juice thingies, right? They're so fun. So these, it's 4 ounces. Okay, these are 4-ounce bottles. So you can grab, say, one of the like 8-ounce bottles of water, and after you drink the water, right, you can use that and see what happens. It's really quite fun trying that. And then, of course, I've got some food coloring. I'm purposefully using a food coloring that's easy for you all to get because I want this to be accessible. Yes, I want it to be cool and fun and sciencey or whatnot and what have you, but I'm using materials that you can easily obtain because you all are scientists and I want you to have a chance to do this, okay? You'll notice that my two... Sure. Try that again. You'll notice that my two samples, my 2 little 4-ounce bottles are on some plates. These happen to be like fancy, biodegradable, whatnot plates. Is that what you have to use? No. But that just happens to be what I have because I'm like, if I'm going to buy disposable plates, let me try to buy disposable plates that are less harmful to the environment. Just throwing it out there. I have my clear soap. Y'all know how we feel about the clear soap. Yes. Okay. So this is Dawn. Dawn is one of the best soaps to use, not because Dawn is doing anything for me. It's just that they're classically known and really strongly formulated. It's one of the best soaps to use for these types of investigations because you get a lot of bubble. You're getting a lot of action out of this. Okay. Then I have a little something under just to kind of protect my table. And inside of a beaker, yes, that's what this container is. Inside of a beaker, I have some water, plain old regular tap water. Did I buy water? Well, in a way. Did I pay for it? Yes, just through the fact of paying for stuff in my apartment. But hi. Hey! I have a very special guest over here on Instagram. She's a very special person. She got married yesterday. Hi, girl. Congratulations again and whatnot. Yes. So I have a graduated cylinder. Okay. So once again, I've got 2 graduated cylinders, people. There's a reason I have 2 graduated cylinders because I want to make sure that I'm not contaminating, my samples. Okay. I want to make sure that I'm doing these things in a way that really makes it a true scientific investigation. Okay. Thank you. I just have to like stop for 2 seconds, y'all, and like give her some love. Thank you. Congratulations again. So excited for her. Like one of my best friends ever, like ever. We've known each other. We even have the same last name. Not related, I kid you not. But she's essentially my sister. Okay, so yes. Okay, I'm going to focus now, I promise y'all. But y'all know how I am. If I'm live and a friend comes on, I have to talk to them like that's just how it is. Okay, so yes. But you know I will eventually get back to my topic, which is right now. So yeah, so we're doing this awesome Alka-Seltzer and vinegar reaction. Remember I told you Alka-Seltzer with the instructions on this medication, and it is a medication. Yes, it is a medication. So my friends who are doing this, like children trying to play around and do this, do not tell your adult family member that, oh, Miss Steph said that I could just play with it. That's not what she said. It's not what she said. Miss Steph said that with adult supervision and permission, you can explore this, okay? and really learn scientifically speaking. Alrighty then. So let's talk a little bit about like the lesson here, right? There's a couple of things I really want to cover today. Two things, okay? Beyond just the reaction. You get to see the fizz. It's going to be fun. Like, that's how I do things, okay? But as far as our science concepts, the things that we're learning today, one thing we're going to learn, we'll learn about the properties of matter, specifically the states of matter, right? Solid, liquid, and gas, the differences between those things, okay? Another thing is a really, really important reaction, which is the acid-base reaction. Yeah? Doesn't it sound important when I say it that way? I promise it is. It is a fundamental reaction that you want to know and understand, okay? So, we're going to do our acid-base reaction, people, okay? And we're going to talk about solids, liquids, and gases. So first of all, properties of matter. How do I know the property of something? Okay, so properties of matter, meaning observable things about matter, matter being stuff. Everything, say it with me, everything in the world is made out of some sort of matter. Matter literally is the science word for stuff. Kid you not, okay? Try to make it sound fancy when you answer the question on the science test, but matter literally is all around us and inside of us, okay? So we are made out of matter. I'm made out of matter. You made out of matter. All of us are made out of matter. Everything is made out of matter, okay? Cool? So that's the first thing. Then matter comes in these different states, as in different forms, okay? One of them being a solid. Okay, a solid keeps its shape, okay, and maintains volume, right? So for example, this doohickey here. Hi. Thank you for joining me. We have some like fun people on today. Hey, Papa Bear, how you been? Hey. All right. So, Alka-Seltzer tablet. Yes, people, we are about to learn from things that you can get at CVS. That is actually literally all of the stuff you can get from CVS, except for sometimes they don't always provide food coloring. Your girl always has to go somewhere else for food coloring. But kid you not, you can try this investigation from stuff at CVS. Literally everything else you can get from CVS. Or some writing. You're with me, okay? So yeah, this is a solid, okay? It keeps its shape. So it has a finite shape and a finite volume. Cool. All right. Liquids, your liquids, all right. Finite volume, a volume that can be measured. The amount of space that the stuff is taking up, okay, can be measured, right? Cool. But the shape, it takes the shape of the container. You see how I'm moving this around, right? You see my liquid moving around in this container? It takes the shape of the container, all right? Now, thanks, Aunt Connie. Now, let's talk about gas, right? Gas, it's all around us. It's very important gas. It's all around us. Air, which is made up of multiple chemicals. But the idea with gas is that it has no finite shape and no finite volume, okay? Gas is going to take up, if you have a gas somewhere, it is going to take up the volume and it will take the shape of the container that it is in. Okay, cool. So do we have gas here per se, other than the air that's like in the bottles and all that kind of stuff? You want to get real technical? Not just yet. But let's see if we can make some gas from our chemical reaction that we're going to make. Okay, that we're going to make happen here. All right. So yeah, so I've got my Alka-Seltzer tablets, right? So as promised, I'm labeling containers, people. Any good scientist has labels. Y'all know when you go to the doctor, they double check. They ask you, what's your name? What's your date of birth? That's so that they can make sure that they're labeling your sample properly. Okay. And so I'm respecting you all, but making sure that I'm labeling my samples properly as well, right? Cool, cool, cool. Here we go. We're doing the tilt. All right. So I have my Alka-Seltzer tablet here on both plates. All right. And here we're going to add vinegar, and here we're going to add some water. So our tablet is our solid, okay, and our vinegar, water, our liquid. Alrighty then. So let's go ahead and measure our water. I'm going to go for 10 milliliters. Remember, today's adventure, we're doing a lot today. Okay. We're doing a lot today. You know, we're learning about the states of matter, or rather, we're observing the states of matter. We're going to talk a bit about acid-base reaction. Okay. And by the way, the cool thing about Alka-Seltzer tablets and the reason they work, the reason they give you that fizz, is because Alka-Seltzer tablets actually have, a little bit much, that's a little much, that's a little much. Alka-Seltzer tablets actually have acid and base together inside of their tablet, okay? And the cool thing about acid and base is that they react together when they're in solution, okay, when they're in a liquid. So in solid form, the acid and base, they're not reacting yet. I'm telling y'all, this is cool, people. Stay with me, okay? So in this particular form, they're not reacting together yet. They're just there, ready to react inside of your body when you do take the medication in the proper form, okay? So not only does dosing matter in medication, but the form that you take it in matters, right? Because this tablet does nothing good for your tummy. You take it wrong, okay? So yeah, anywho, all right, so I've got my 2 liquids. I measured out my 10 milliliters of vinegar. Notice I'm keeping them separately so that I know where things are, okay? And my 10 milliliters of water. So another thing we're doing today is we're comparing reactions. We're seeing, I wonder if there will be a difference between this clear liquid, the liquid that is directed on the container, okay, and this clear liquid, the liquid that Miss Steph just decided that she's going to do, okay? All right, so I've got my soap. If you're trying this at home, can you use soap that has pigment? Yes, you can. Okay, color makes life better, I kid you not. However, do I tend to like to use clear? 2, 3, there we do. I tend to like to use clear soap in my investigations and experiments. Yes, I do, because it interacts less with what we're making. Okay, so I'm gonna move this over here out of my way. All right, I just put soap. I want to be clear what I did. Okay, we're doing a lot of stuff. We're talking about a lot of stuff today. I want to be very clear what I did just now. Okay, I have my tablet here. Notice how I'm not combining anything yet. Okay, I'm setting everything up. We're learning about Alka-Seltzer today. We're exploring if there's a difference between how Alka-Seltzer reacts with water, this graduated cylinder, and how Alka-Seltzer reacts with vinegar, this graduated cylinder. Cool, 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 cool. But in my organized scientific fashion, right, I want to make sure that I'm doing things in a controlled manner, right? So I've got my labeled containers. The containers are the same size. The amount of Alka-Seltzer I'm going to use is the same. The amount of liquid I'm using is the same. The only thing that I did not quite measure was that soap, right? My liquid soap, okay? But I know in comparison, my squirts, I've been doing this for a while. So I know I can get about the right kind of squirts in, okay? The next thing I'm going to add is food coloring. Do you have to add food coloring? Put in the comments below. Do you have to add food coloring? Do you absolutely need food coloring to make this work? Do you think so? Do you think so? Do you think so? Do you think so? Anybody? Do you think so? Is food coloring? For my buddy, I'm going to use blue. I'm going to use blue. For her, I'm using blue. All right. Use blue. Everybody knows my color is purple. But for the newly misses, I'm going to use blue. Alrighty then. So, no, I don't think so. First of all, I love the interaction. I love when people interact. Thank you so much, kindly. Okay. So, do you have to use food coloring? No, the reaction will still work. But is it as fun? Huh? And would it really be a misstep reaction if you didn't use food coloring? No. Okay. Alrighty then. So I'm going to go for, because I really want this to pop, I'm going to go for a ridiculous amount, which is a lot for me. I'm going to go, let's go with 3. 1, 2, 3. And since I'm doing a as controlled of an experiment as possible, I want to come over here and use 3. 1, 2, 3, right? Remember, for this particular activity today, for episode 4, season 2, Science with Mrs. Steph, we are exploring the vinegar and Alka-Seltzer reaction. To do that, we are trying to keep everything else, quote unquote, even, everything else the same. All right. And for my folks, my scientists of different ages and different educational levels and different scientific interests, I definitely say that this is always a fun one. And this is always something, you can always learn something from this. And you can demonstrate your knowledge of acids and bases, as well as your knowledge of the basic properties of matter, being the states of matter. Already then, so I'm going to add my water here. And I'll explain why I'm adding these in the order that I'm adding them in just a second. Adding my vinegar here. Okay, so I'm going to keep these kind of separate should I decide I want to add more later. All right. So I'm going to give this a swirl. I want to make sure I'm combining, that I'm combining my 3 liquids together, right? Can anybody name the 3 liquids that we've added inside of this container? Our 3 liquids that we've got inside of here, right? Yeah. So our 3 liquids, right? We've got our clear liquid, either vinegar or water over here. We've got our soap in both of them, and our food coloring is actually in liquid form today. You can do solid pigment, but today we're doing it in liquid form. Alrighty then, so yes, see what? Fab, fab, fab. Love, love, love. All right, so now let's go ahead and drop this. We've been on for almost half an hour, so it's time for me to almost roll out. Because y'all know I'll just sit and chit chat forever. So let's drop these. 1, 2, 3. What's happening? Well, that's a problem. Did that work? No. Right? I got to do a break. Okay. Break. Boom. All right. Now they're going to fit inside of my container. Okay. Trust me, I did that on purpose. I know for a fact that you have to break these. Alrighty then. 1, 2, 3, boom. All right. Let's see if anything happens. Let's see if the reaction is going to be the same, different. Oh, sorry. Silliness. Absolute silliness. So as this is reacting, I want to kind of talk a little bit, well, probably a lot, to make sure that we're clear. Remember how I was telling you that the acid, there's acid and base. There's an acid and a base inside of our Alka-Seltzer, right? Our Alka-Seltzer tablet, okay? And remember how I was telling you the vinegar, right? The vinegar and water, they look a lot alike, but are they the same thing chemically? Absolutely not, right? The vinegar is considered an acid. We consider vinegar an acid, okay? Water we consider to be neutral. So one of the things that I'm noticing that hopefully you all are noticing as well is that we're getting a larger reaction, okay? If I put them side by side, I'm gonna actually put this back up. All right, it's not important for you to see my face. Y'all know what I look like at this point, but I do want you to see this. You see how side by side the vinegar is actually going, yeah, right? It's giving a quicker reaction and a larger magnitude, okay? Because the vinegar has acid inside of it, right? You're getting, it's almost like a double acid kind of situation. All right? Let's hold them like this. See? Got a different thing, right? I'm trying to make sure y'all can actually see over here on YouTube. Good. Okay. Okay. I'm giving it a bit of a shake. The other thing that's going on is that it's taking a while for it to dissolve. So the thing that's happening, just so we're clear, is that the tablet is dissolving inside of the liquids. Alka-Seltzer only functions, only does its thing, okay? Like I said, it does its thing best in water, which is why you're supposed to take it in water, right? When you take it as medication. But it only reacts in a water-based liquid, okay? So if I try to put this in oil, it's not gonna do it, okay? We get a whole nother thing that happens if you add oil, water, and Alka-Seltzer together. There's a name for that particular investigation. If anybody knows the name of doing oil, water, Alka-Seltzer tablet in a bottle with food coloring, go ahead and drop that down in the comments as well. So wouldn't it be fun if we made one of these overflow? I think so. All right. So let's go ahead and do that before we log out today. Okay. So the way that I'm going to do that is to use my vinegar sample, because I know we just learned, right? Didn't we just learn that the vinegar sample gives us a stronger reaction, a quicker reaction? Okay. So let's see if we can get this puppy to overflow by adding more acid to our reaction vessel. And yes, I am making sure that I'm using the correct graduated cylinder. All right. Remember, I don't want to contaminate things. These are things that we need to know as scientists. There's a way that we're doing things. All right. So we've got, I would say we have enough blue, but why not add more? I'm going to go up to 5. Some simple math. I already added 3, 4, 5. So I'm going to add an additional 2 drops so that I'm getting a total of 5. All right. This particular tablet is already broken up. Okay. Based on how big of a reaction we got with just 10 milliliters of vinegar, right? A squirt of soap. You notice we needed very little soap to be able to get this puppy to work, right? To give it to do this, which is cute. I mean, it's cute. It did something. However, overflowing reactions are always more fun, okay? So we're adding 10 more milliliters of vinegar. Just to be clear, I'm adding vinegar to this. Is this how you would take the medication if you were taking it? No. Okay. So for my kids in the room, no, we're not eating or drinking this. Okay. Alka-Seltzer is for adults. Okay. We don't ingest our science. No, thank you. Okay. But this is a fun investigation that you can do with the permission of an adult for all of my kids on. Alrighty then. So the thing that I'm going to do is I'm going to need to add this quickly. Do we know why? Why do I need to add everything quickly? Stuff is already in my container, right? Okay. So my Alka-Seltzer is going to react to the vinegar that's already inside of there, right? Cool. All right. Whoa. Didn't that react a bit faster? Okay. And we're starting to get some movement. Yes, true, right? So technique, my speed, the speed at which I add, the speed at which I add my reagents together makes a difference as well. Okay. Additionally, we already had liquid inside of the container, right? So we didn't want it to sit. We wanted to make sure it got a chance to react. What? Who's having fun? Whoa. Okay. So I know this looks very similar to the elephant toothpaste reaction. I do use these bottles for elephant toothpaste sometimes, but this is a different chemical reaction, right? The elephant toothpaste reaction is a cleaving reaction. There's a separation of my one of the oxygen off of the H2O2 molecule. Whereas in this reaction, the chemicals are coming together to create carbon dioxide and water. Kid you not, that's basically what's happening. Some other stuff is in there too, but just work with me, okay? So inside of, I've talked about this before, but inside of this, we have three main things. Anhydrous, meaning crystallized, okay? Anhydrous citric acid, remember I told you, there's an acid and a base inside of here. There's also a little something else in here. Okay, we've got citric acid, aspirin, which is a pain reliever, which is another reason why children do not take this. No, thank you. Unless an adult has said it is okay. And sodium bicarbonate, which is another word for baking soda. Okay, so people, it has been fabulous having you join me today for Science with Ms. Steph. Like, I thought that was fun, right? Didn't we have a good time? Remember, over the next, frankly, this year, I think this school year, my thing with the Science with Ms. Steph's videos are going to be the fact that we're going to do a mix of requests and giving you a peek into what we did over the summer, because I missed you all. I didn't get to hang out with you all over the summer, even though I had a fabulous time with the young people that I had in my class. I know that we had a smaller group with us this summer. And so I'm going to make sure you get to do some of the stuff that we did. And we did this particular activity. We did the Alka-Seltzer and Vinegar reaction. We called it the AV reaction. I thought it was a fun, little name for it. Okay. So yes, solids, liquids, and gases, and the acid-base reaction. Once again, it's been Ms. Steph. Thank you so much for watching. I appreciate each and every one of you. Thank you all for your support over the years. And here we go. Remember, this is year 10 for Science Club. So we got to make it fun.